Okay, so the next item that we're going to talk about is if we have similar triangles, so we're going to be sort of back to those two separate triangles, what else do we know? So if you have two triangles that are similar, then that means the perimeters are going to be proportional to the measures of the corresponding sides. So instead of just writing a proportion in order to find a missing side, it turns out I can write a proportion and find an entire perimeter. So the first example here says to use the similar triangles to find the perimeter of triangle ABC. So if you look, ABC is our small triangle here. I only know the bottom of it is 5. I have this larger triangle. I know all 3 sides. So yes, I could set up separate proportions. I could find my missing sides in my small triangle, and I could add everything together, but that's going to be more work than I need to do. So instead, I'm going to use the fact that I can find the perimeter of this big triangle to sort of help me out. So if I take the big triangle, and the first thing I want to do is I want to find the perimeter of the big triangle. So the big triangle, remember, perimeters just add your sides together. So 37 plus 12 plus 35 is going to give me a perimeter that is equal to 84 for this large triangle. So if I know this, I can set up a proportion to find the perimeter. So if I'm setting up that proportion, that means that the perimeter of the little triangle over the perimeter of the big triangle, which we just found to be 84, has to equal, and then your second fraction is going to be a set of sides. So the only sides that I know for both triangles is this bottom. So the 5 over the 12. And now it's just a matter of solving this just like we've solved all of our other proportions. So we're going to have 12 times p. 84 times 5 is going to give me 420. And lastly, you're going to divide both sides by 12. And so the perimeter for triangle ABC would have a value of 35. So you're going to set up a proportion, one fraction comparing the perimeters, one fraction comparing the one set of sides that you actually know. So if I take this same idea to a second example, again, I'm trying to find the perimeter of triangle ABC, but now my triangles are overlapping each other. And triangle ABC, if you notice, go around the outside, A, B, C, that's going to be the large triangle. I still need to find the perimeter of the triangle that I do know. So this small triangle, if I take 18 plus 12 plus 24, has a perimeter of 54. Okay? The other thing I'm going to need is I'm going to need a set of sides to compare. And right now, I need to put 2 lengths together. Look at your left-hand side here, right? If I put these together, excuse my writing, 3 and 18 would make this whole thing 21. So the whole thing from A to C is 21, D to C is 18. That's going to be my comparison of sides. So setting up my proportion, perimeter of ABC that I don't know over the perimeter of 54 that I do know. On top, the big triangle ABC has a side of 21. The small triangle has a side of 18. Again, making sure we're setting that up accurately. And so cross multiply, oops, here's your 18p. 54 times 21 is going to give you 1,134. Divide both sides by 18. In this case, the perimeter of what is the larger triangle is going to be 63. So the key to this is you're using a proportion. One of your fractions represents the perimeter. The last bit is that if you have two similar triangles, it means that the measures of the corresponding altitudes, medians, and angle bisectors are proportional to the measures of the corresponding sides. That's a lot of information, but basically this is what it boils down to. If triangles are similar, we know that their sides are proportional. We've been doing that. All this is saying is it means all of their other little pieces are proportional, like an altitude or median. So if we look at some examples, the top one here, see how the X is inside? That's an altitude. Remember, it comes down, it makes a right angle. It's saying that that altitude has to be proportional, just like sides would be, which means I can set up a proportion using my fractions. So if I'm just comparing this first triangle to this second triangle, the 20 would match with the 6. And then on the inside, the 15 would match with X. And once you set up your proportion, the cross multiplying and the solving should be sort of the quick and easy part. So you're looking at your 20X, and 6 times 15 is going to be 90. And so divide by 20, and you're going to get X is equal to 4.5. This next one works the same way. This is going to be a median instead of an altitude. I'm not making a right angle. I'm making two congruent pieces, but the process is the same. Your 24 matches up with the 16 to make one fraction, and your X matches up with the 9. So 16X is equal to 216. Divide both sides by 16, and we are getting 13.5. Remember, when we're dealing with proportions, we're not always going to get those nice whole numbers. Things like 0.5s really shouldn't set off alarm bells, but it is possible to get other decimals as well. And so if I just slide down here a little bit, oops, and bring this one up, this is the same idea, except this one's an angle bisector, but I'm going to do the same process. I'm still setting up proportions. So again, just comparing the first triangle and the second triangle. 16 would match with 10, and 18 would match with X. So 16X, 180, missed my X. There we go. Divide both sides by 16. This time you're going to get an 11.25. You could keep that as 11.25, or you could round it to an 11.3. Both would be accurate.